They don't look like warships. They don't sail like them either. And if you're lucky, or unlucky, depending on your position, you'll never even know they're there. The US Navy's stealth ships don't announce themselves with towering superstructures or sweeping radar dishes. Instead, they slide through the ocean with hulls that deflect radar, exhaust systems that cool their signature, and lines that break tradition as deliberately as they break waves. To the casual observer, they might seem like science fiction or experimental prototypes. But they are not. They're very real, very operational, and quietly redefining what naval presence means in the 21st century. In the early 2000s, the US Navy identified a need for agile, multi-mission ships capable of operating in coastal waters. This led to the Littoral Combat Ship Program, which produced two distinct classes: the monohull Freedom variant and the trimaran-hulled Independence variant. The Independence class, developed by General Dynamics and Austal USA, features an aluminum trimaran design that offers enhanced stability and a spacious mission bay. The Independence-class littoral combat ships feature innovative design elements tailored to enhance agility, flexibility, and mission capability in coastal and near-shore environments. Unlike traditional monohull designs, the Independence class employs a trimaran hull with a wide, stable central hull flanked by two smaller side hulls. This arrangement significantly enhances stability, especially in choppy, near-shore waters. The trimaran structure gives the Independence class an exceptionally wide beam, measuring 104 feet. This greater width allows for an expansive flight deck and mission bay without compromising the vessel's ability to operate in littoral zones. With a draft of just 14 feet, these ships can operate in shallower waters than most large naval vessels, a crucial advantage for missions that require proximity to shorelines, such as anti-piracy, disaster response, and mine countermeasures. The Independence class has one of the largest flight decks on any warship of its size, spanning over 1,000 square meters. This capacity accommodates two MH-60 Seahawk helicopters or multiple unmanned aerial vehicles, which are increasingly important in naval operations for surveillance, reconnaissance, and even strike capabilities. These ships were designed with a mission bay that occupies 15,500 square feet, optimized for modularity. This area can house mission-specific payloads for various operations, including mine countermeasures, anti-submarine warfare, and surface warfare, with packages designed to be swapped out based on mission requirements. This mission bay can hold mission packages weighing up to 180 metric tons, giving the ship substantial cargo flexibility and the ability to carry everything from specialized equipment to additional personnel. This ship is fast for its bulk. The Independence class employs a hybrid propulsion system, combining diesel and gas turbine engines, allowing for both high-speed sprints and efficient cruising. The ship can reach speeds of up to 44 knots, which is particularly valuable for rapid response and pursuit in littoral zones. 4 steerable water jets power the vessel, providing a high degree of maneuverability. This propulsion choice not only allows the ship to make tight turns, but also minimizes the risk of entangling with underwater obstacles or mines, a common hazard in shallow coastal waters. These are all good, but the real speciality of these ships are their stealth capabilities. The Independence-class littoral combat ships incorporate multiple stealth features designed to reduce their visibility to radar, infrared, and acoustic detection, enhancing their survivability in contested environments. The ship's superstructure and hull are built with angled surfaces that help deflect radar waves away from the source rather than back toward it. By reflecting radar waves in multiple directions, the ship minimizes its radar cross-section, making it harder to detect by radar systems. Unlike traditional ships with various protruding parts, like masts and sensors, the Independence class has a more streamlined, integrated structure where equipment and sensors are carefully placed to maintain a smooth, clean profile. This reduces radar clutter and the number of distinct points that could reflect radar signals. The ship's structure includes radar-absorbent materials, or RAM, that can absorb some of the radar energy hitting it, further lowering its RCS. RAM coatings are often used on specific areas of the vessel, such as around the superstructure and along the edges of panels where radar waves are most likely to reflect. Naval vessels often emit heat from engines, exhausts, and other equipment, creating an infrared signature that can be detected by infrared sensors. The Independence class incorporates heat management systems designed to dissipate and control heat emission from its engines and exhaust systems. The ship's exhaust systems are designed to redirect hot gases and cool them before they exit the vessel. By cooling and dispersing the exhaust over a wider area or channeling it into the water in some naval vessels, the ship reduces its infrared profile, making it harder for infrared-seeking missiles to lock on. Special coatings on the ship's exterior help to minimize heat absorption from sunlight. These coatings can reduce the ship's overall temperature, thereby lowering its infrared signature in warmer environments. As we mentioned a few minutes ago, the Independence-class ships use a water-jet propulsion system instead of traditional propellers. Water jets create less noise than propellers, as they don't produce the cavitation bubbles that are common with propeller-driven systems. This quieter operation makes the ship less detectable by sonar, especially by submarines that rely on underwater acoustic tracking. The ship's machinery and other noise-producing components are installed on vibration-dampening mounts, which minimize the transfer of mechanical noise to the hull and the surrounding water. By reducing these vibrations, the ship lessens its acoustic signature, making it harder for underwater detection systems to identify its presence. The trimaran hull design not only provides stability, but also minimizes drag in the water, reducing the turbulence created by the ship's movement. This further limits the noise generated while the vessel is underway. The Independence-class ships are equipped with systems that allow them to control their electronic emissions. This means that the ship can reduce or disable active transmissions when necessary, relying on passive systems to detect other vessels while remaining less detectable. EMCON, or MCON, can significantly decrease the ship's visibility to enemy electronic surveillance systems. For situations where radar must be used, the ship's systems are often designed with low probability of intercept radars, which emit signals that are harder for other radar detection systems to intercept or track. LPI radars work by using the combination of lower power emissions, spread spectrum techniques, and frequency hopping to avoid easy detection. The ship is built with minimal external equipment and protrusions to avoid creating shadows and visible edges that could be more easily identified by an adversary. This streamlined, low-profile silhouette makes it more challenging to visually detect the vessel, especially at longer ranges or in conditions where visibility is limited. The Independence class is designed for a relatively small core crew, with extensive automation to reduce workload.